Okay, this is a quick lecture to get things started with trusses. As as you can see, I am not streaming this, I'm recording it because the reliability of the stream was a little bit off. So I'm going to do this on trusses using the recording. So let's look real quick at the website that it may change over time. Let me describe everything I've put here. This is OneNotes for our class that will be built up. You click it and it takes you to a location on the tech service thing, shared point, and in a second you will see a lecture on trusses that nothing's there yet. However, as I write here, what you will find, as I write there, you can go back and suddenly it's put there almost instantly. So it's very interesting. As I'm writing on my laptop, the lecture note comes out almost live. So in the middle of while I'm making my lecture, you will be able to do this, especially when I'm streaming. If you had two monitors and the thing was set up, you can do that. So it is almost live, and that is a Microsoft product. Very good. Well done. This is going to be the location where the videos will end up. Currently, you'll see I did some tests. You can see I'm laying this down. So this was my first streaming test. This was the test I did in the middle of statics. It was a live stream. I did a couple of live streamed, and I did some recordings. This is for dynamics. These two are for dynamics. This one's for engineering econ. And shortly, this video will be listed right there. I will try to list them or set them up in a manner in which the first word is going to be the course. Like engineering econ, dynamics, or statics. Let me go and fix this one. But I'll fix it in a little bit. This is general information which could apply for any course, so I'm not going to put a title on it. Everything else will have dynamics, statics, or engineering econ, or econ on it. So as we go through here, let me go back. The next is playlist, and that should go down here. So the top three are the important. Online text. What I'm going to do is I'm going to refer to this a lot. This way you don't have to worry about finding your books or anything like that. I'm going to lecture on this section here, joints and sections. We're going to talk about, we'll talk for a minute on two force members, but mostly trusses, joints, and sections. So I would encourage you to take that link and really look at what he's got there. It's a fairly good set. If you look at the trusses, you'll see him describing the trusses, some examples of trusses, analyzing the trusses, and he's got a video sitting up here where he talks about it. So done a very excellent job on this website. So I would definitely say this is what I'm going to use here. So let's go back one more. So the Blackboard site outside that is, those are our main things. You'll find the videos through the YouTube channel. Again, it just takes you to the main upper location there, sitting right there. And as the videos come up, What I might do as well is try to place them in a playlist and try to remove all the other playlists that I've got too many, and just come up with the statics, dynamics, and econ playlist. So let's get started on a truss. He starts with methods of joints. He's got a simple case right here. Very nicely done. 10 meters across, 5 meters high. Members A, B, C, D, E. On the left, what you'll see is a support that sits right there that's capable of taking a load this way and that way because it's bolted to the ground. You'll find another ball-like thing which is only able to take a force this way. So I've got a vertical force here and only a vertical force here. So going back to the website, he talks about breaking it into a free body diagram. You can only have a vertical force here because of the supporting member. You can have a vertical or a horizontal force here because it's a pin. And so now you've got this. Okay. Now where did he get his 3 kilonewtons for here? Let me show you. Just simply take a picture of this thing. I could have taken it off of that. But I'm going to go ahead and drop it into my OneNote and go back, make it, well, here, I'll just slide it up. If I do this, it makes it full screen automatically. Here, now, it's a kind of oversized. Let's just shrink this down a little bit. Here's what we're going to do. Now this little, that little dot in the middle disappears if I do this. So I'm going to use green. So I'll just pick this point right here. He labels it 1. I'll sum the moments about 1, saying that that's positive. They've got to equal 0. So this force in a moment arm of 10, it's going this way, which is opposite, which becomes minus, and it's 6 kilonewtons and 10 meters. Then you get this one. This one's 20 over. It is actually going this way. Plus 20. That's the length. And he's labeled it F, R, I think that's Z. I can't read it very well here. I think it was a problem with my clip. Let me go back to the website and see. Okay. I'll just say, I can't tell. I'll just call it whatever that, I'll just call it what I can see it possibly being. I'm going to call that, I think it's FRZY, but it might be 2Y. But it also might be 4Y. But I'm just going to call it FR. So the force vertical on location 4, pin 4, is equal to, let's take this and take that, move this to the other side, and you get 60. Bring that under 20, and you get 3. And that's not too surprising. That's exactly what he ends up with down here. is that 3 sitting right there. So there's a 3 right there. It just so happens the next thing you could do is you could come in and say, well, if this in fact is 3, then sum of the forces in the y equals 0 tells you that this being positive tells you that 3 minus 6, here's your minus 6, here's your plus 3, plus this f resultant at the right side, which this will be the value right here, that has, by nature, that has to be 3. Well, not too surprisingly, that's what he gets right here. So the next step is how to break each node apart. Okay, you could start at the left end, the right end. It really doesn't matter. But before you actually do, you should deal with one other possible component, and that is this. Okay, let's erase all this. If I know this is 3, and I know this is 3, now take this diagram here. Here, let's do this. Oh, wait. Move it over to the right. We'll sum the forces on the whole structure in the x direction equals 0. Equals to, I have this force going in the x direction, F R1x or whatever. There's no other x force. So by nature, it's not there. Doesn't exist. So that's why you don't see that there. So, with that in mind, hang on, I'm trying to adjust the volume here. With that in mind, how do you determine FA? What you find out here, if you take a quick look, give it a second. Since there's a member sitting in here, this member is doing like that. Essentially, you're breaking the member away, replacing it with a force. So obviously these two are equal. These two are equal. These two are equal. And these two are equal. Oh, and these two are equal. So that's what the members, that's how these members are set. So if you take FA and you want to find FA and or FB, let's just look at specifically that particular one. Now what you notice is this one looks like the mirror image of that one, but we don't want to do that right off. Let's start with this one. By doing that, here's what we'll do. We'll just take his picture and let's see, how do you do this? I guess here, get rid of that, get rid of that. I guess I can snip it and drop it right back over into. So as you move down, to find out, there's your picture. So you got a node here, right? So all you do is sum the forces in the x equals 0 and sum the forces in the y equals 0. Okay, so I got something interesting in the y. I've got a 3, and I'm going to drop the k Newton and just put the numbers in there. And you got this FA going up. So we're calling this positive. FA times cosine of some angle. Can we figure out that angle? Well, it's a 5 and a 10, so it's the angle associated with that. So essentially, if you had a value here which was 5 and a value here which was 10, did I do that right? 5 and 10. Then, and actually, I've made an error there because that FA, if that's going to be my angle, it's going to be the angle associated with the value going in the Y, which is a sine. Okay, so there's a couple ways you could do this. One is square root of 10 squared plus 5 squared equals the square root of 125. I think that's it. So 5 is to this. And so that's it. That's the equation. You've got a component going this way and a component going that way. What you find out as you move the 3 across, you get a minus 3 equals to FA times 5 over square root of 125. Okay, so now that you've got that, then what you're looking at is a pretty simple setup, but FA would equal to, and let's break it away. And what we'll do is, if you look at those standard videos there, you'll find that I have octave in that list. Here's octave coming up, and here it is. I'm going to look at my equation. I'm moving it around on this page. There it is. So 3 times the square root of 125 divided by 5, I think, 6.7 right here. It's a minus 6.7 roughly. Let's see if I did it right. He probably did it right. I'm not guaranteeing that I got anything right. Oh, okay. You'll probably have to look at his video. There's no reason for me to show his video, since he spent the time doing it, and I'm actually, I mean, if you look at that, he's doing it and probably doing an excellent job there. So there's no real reason for me to continue this. The key is, look at his video and look at this. I'll come back and do an independent problem. And here's some work problems. I would say look at this one. He has a PDF solution right here. Question 2's excellently done. There's a PDF solution and a video. And then he's got a 3D one. Excellent. 3D truss. And he's got a practice problem. I like that. Very nicely done. Show the correct answer. He's got a practice problem here. So I think, actually, I like these practice problems. So I think I will get back with you, but I think these are nicely done. Wow. Very nicely done. Okay. So I'm going to conclude this video and add some more later. I've got some, so let's, we'll stop it. I'll post it and I'll send you a link.